This is Euclid Book 8, proposition number 11. And it says, between two square numbers, there is one mean proportional number, and the square has to the square the ratio duplicate of that which the side has to the side. Now, here we go. Here's your diagram. And this time I went ahead and associated numbers with this, and I hope I got this right. Okay. Let's get into this. Let A and B be square numbers. Well, A, of course, is 4, and B, of course, is 16. You can write this down if you like. Okay. And let C be the side of A and D of B. Well, we're going to say the C is 2 and D is 4, and you'll see why in just a little bit. I say that between A and B there is one mean proportional number, and A has to be the ratio duplicate of that which C has to D. For let C by multiplying D make E. Okay, well 4 times 2 is going to make 8. Now since A is the square C, now since A is a square and C is its side, then therefore C by multiplying itself has made A. That's where we got the 2. 2 multiplying itself makes 4. For the same reason also, D by multiplying itself has made B. 4 times 4 makes 16. Okay. Since then C by multiplying the numbers C and D, now let's stop there. C times C is of course 4, because 2 times 2 is 4. And C times D, which 2 times 4 of course makes 8. Okay, so since then C by multiplying the numbers C and D has made A and E respectively. Now let me show you this on the illustration here. C times itself makes A, and C times D makes E. That's what they're trying to say. Let's go on here. Therefore, as C is to D, so is A to E. Therefore, as 2 is to 4, so as 4 is to 8. And that's by Euclid Book 7, proposition number 17. For the same reason also, as C is to D, so is E to B. Okay, as 2 is to 4, so is 8 is to 16, which is true. And this is by Euclid Book 7, proposition number 18. Therefore also, as A is to E, so is E to B. Well, as 4 is to 8, okay, so is 8 is to 16, which of course is true. Therefore, between A and B, there is one mean proportional number. I say next that A also has to be the ratio duplicate of that which C has to D. For since A, E, and B are 3 numbers in proportion, okay, now, as 4 is to 8, so is 8 is to 16, which is a continued proportion, okay. Therefore, A has to be the ratio duplicate of that which A has to E. Okay, so the ratio of 4 to 16 is 1/4. Okay, and the ratio of AE is 1/2. You say, how do we get that? Okay, 4 over 16 is actually 1/4, and 4 over 8 is 1/2. And 1/4 is a ratio duplicate of that of 1/2, because you get it. If you don't, let me know and I'll explain it to you. And this is by Euclid Book 5, definition number 9. But as A is to E, so is C to D. Well, as 4 is to 8, okay, so is 2 is to 4. They're both 1/2. Therefore, A has to be the ratio duplicate of that let me say that again. Therefore, A has to be the ratio duplicate of that which the side C has to D. I think I've pretty much proven that. All right. I will tell you more. Excuse me. I will tell you more in a future video. Stay tuned.